So welcome in this second meetup. This meetup will be about ASP.NET authentication, and it's about to give you a glance what's happening under the hood of ASP.NET authentication. Actually, this is not a PowerPoint. This is completely generated by something called MARP, and it's actually generated from a Markdown script. So it works perfectly well in Visual Studio Code. However, when I display it in this, maybe there is different resolution, and as it's generated on the fly, somehow the ends are missing. But I will tell you everything interesting anyway. So the identity in context of ASP.NET lives in HTTP context, and this HTTP context has something called principal. In our case, it's ClaimsPrincipal, and this principal keeps identities. Each identity tells, okay, this user is something. Yeah, there is like one identity that represents all of them, and there is another property if it's in or method that can tell if the user is in a role. And what's the claim? So the claim is a valid or true statement about the user. Typically, it's a value. It's a key value pair. For example, race human, or gender male, or name and some email, or something like that. And we will then use the claims about the user in the authentication, like down the road. And these claims make an identity. So the identity is kind of a bag of claims, let's say. And as you see, this claims principle has claims identity, and it consists of claims. So what we really want to achieve is to get some authentication result. The result may be a success if the authentication was fine. The user is likely who we think it is, and then it contains an authentication ticket, and the authentication ticket is that principle that we will then paste into the HTTP context. And if the authentication wasn't successful, there is a failure. Usually there is an exception, and there might be a situation that we have like more than one authentication handler. We can process the request multiple authentication ways, and if the authentication handler we use can't say anything about the user and its authentication, it returns simply none. And speaking about the handler, the role of authentication handler is to process a request and to give the authentication result we saw on the previous slide. And this authentication handler, by default, it's created per request, so it's transient. And so don't restore anything you want to cache or anything like that, because it will be dropped on the floor. And this authentication handler uses a bit interesting way to start, because it has initialize async method. And this initialize async expects two parameters. It's authentication scheme. That's the scheme of the authentication, let's say foo or bar, and the HTTP context. So as it's transient, you simply keep both in the instance of the handler. And then there are three methods which are used for different flows. First is authenticate, and this authenticate async will return the authenticate result. And usually if the result isn't successful, the challenge is then called. So the user will, in some flows, get another chance to authenticate, for example, using second factor, or if it's a cookie authentication flow, he will get a chance to write some login and password and create a new cookie with a wallet token, something like that. And it's usually when the authentication fails. But when another flow called authorization fails, there is another method called forbid async. And this method is solely for the situation that the user, we know who the user is, but we see that the user wants to do something he really shouldn't. So that's usually for like giving the right response to explain why the operation the user wanted didn't happen. And as we see, the authentication scheme that is used in the initialization and throughout the process, this is very simple, let's say, handler. It has a name, for example, bearer or basic, or maybe a foo or something. A display name, what we will see in our logs and everything, and a handler type. And the handler type is the concrete implementation of the authentication handler. So if we will take a look on some example how the authentication handler implementation may look. So we see IIS server authentication handler internal. You know IIS, right? It's pretty popular everywhere. Everyone loves it. So that's why I picked that one. And you see that there is this initialize async, simply the context and scheme are captured in fields. And there is another thing that as it is an authentication for IIS server, it will get a type that it knows it's there. And usually this is used for situations you are authenticated on the IIS level, and it's then propagated down the road. And you see that when the authentication fails, you will simply get response status code 401. And if it's forbidden, you will get 403. Easy peasy. So the authenticate async, you see that we actually get the Windows user. And then if the user isn't authenticated, we return success. Otherwise, we return no result because the user may authenticate some other way, and we won't want to get into the way with this. So there are a couple of these built-in authentication handlers, usually provided by server implementations. So there is one for HTTPS and one for IIS. And oh, sorry, this one was fine when I checked, like 5 minutes before. So anyway, there should be written authentication handler. And this authentication handler is like a base class for application level authentication. There are like couple built-in handlers. Maybe you all know JWT bearer handler, which is for authenticate by bearer scheme using JWT authentication token. There is an implementation for Kerberos and and TLM for certificates called MTLS, mutual TLS, and couple others. These implementations are application level implementations. So most likely they will do more or less the same you want to do, and they are good inspiration made by the .NET team, so you can learn from the best. And if it was visible on the previous slide, you could see that the base class is actually a generic class, and it expects one generic parameter. And this generic parameter has a constraint of being authentication scheme options. And this authentication scheme options gives a couple interesting options for all authentication handlers by default. There is one interesting called events. You see, it's an object, and in another you will give a type. So these events are meant for hooks. So every time you will see some authentication handler and it's correctly implemented, you may take a look what types is in the events type, and you will, or you should be able to see all the hooks that it provides. Usually, for example, the GVT bearer handler provides like, I think 16 or something hooks. It's like before the authentication as such, before the token is parsed, after it's parsed, before it's validated, after it's validated. Pretty much every step has a hook. So you can interfere to any part of the authentication and, for example, change the principal, change its claims, and do basically whatever you want. And another thing is these forwards. And these forwards are meant for some, let's say, automation. If you want to change the authentication scheme for something else in some situation you define, you can do that using this forward. So it's a scheme that will be forwarded for default, for the authentication as such, for challenge, or for sign in and sign out. And you can then change the scheme dependencies dynamically on the fly.
Why does it return string, or what's the return value of the forward thingy?
Of the method?
Yeah, of those forwards. Why is it string?
Yes, because the selector is another piece that can be used for, it's a map between the forwards and the schemes, or so between the in schemes and out schemes, let's say. And this selector is then used to get the default one. When you I think the flow is that when you don't have any scheme, you will get this one as a default, and you can get it from the context. So you will get the context, and you will decide dynamically which forward for default you will get. So I mentioned the authentication handler, the base class. And here you see the base class with partly cut code, because it's much longer actually. But to get a look what we can use here, you see that here are the forwards used. So every time you want to authenticate, you want some target. That's the forward authenticate. That's the scheme that you want to use, if there is any for that. So let's say that you got a request which had a scheme bearer, but you want to serve all these requests by another scheme named bar. So this way you will say, okay, let's use another scheme instead. And here you see that on the context is instead called the target that you have there. And if you don't switch the scheme, this one is then proceed further, and you see that there is handle authenticate once async. That's actually a method that you can override, and you will write your authentication there, and the return some result, and then there is that logic that if the result doesn't have a failure, which means that it's a success, it will fill and lock the result, and then it will return the result. So, and a bit lower, you see that again there is a challenge. So when the authentication was unsuccessful, you again resolve the target. So you see that really these forwards are used throughout the handler. And again, you can switch the authentication. So for example, if you are unsuccessful for, let's say, foo authentication, you can try it with bar authentication. This is likely used in some remote authentication flows like OpenID or something like that.
Is it common to actually change the names from like the standard ones from there, etc., to use some super custom? Or is this just for the sake of the example that you
You can want to do it. I think that actually there is a company that does it actually. When you want to use one, let's say, very common authentication way, then it will try to parse your artifact, your authentication artifact, and if the parsing is unsuccessful, it will try to change the scheme to some older version of the same authentication.
for actually kind of versioning and backward support.
Pretty much.
Okay, that makes sense.
So that was about a handler. So let's say that we write our own implementation and we want to register it. So in our startup, we will say that we want to add an authentication, and we add a scheme where we fill the authentication options that it's an implementation of the options we already saw. And then we provide the handler, and we say which scheme it is relevant for. And if we use this add authentication, it will actually register 4 services. One is iAuthentication service. And this service is actually not used by the authentication as such. It's used by authorization flows. So if you don't use authorization, you won't use it at all. Then there is iClaims transformation, which is your chance to say, okay, I have some claims principle here, but I want to, let's say, add some claims, or maybe change, or maybe remove, or do some additional transformations. The iAuthentication handler provider, it's a piece that will always give you the handlers for some authentication scheme. So let's say that I have a bar authentication scheme, and I will want to get all the handlers that are associated with this, and there may be multiple handlers. Let's say there are 3. I will get 3 of them, and I may traverse them till I get either success or failure. Usually I should get none if the handler isn't the right handler. So that's the idea of this. And the authentication scheme provider, it will give you the scheme, and again you see that there are like the defaults. So you may set a default scheme, and we will see the default scheme in a demo in the very end. And it will like give you always the scheme that should be used. So first you will get the scheme, then you will get the handlers using the scheme, then you will authenticate the request, maybe using the authentication service, and then when it's success and the claims principal is created, you will get a chance to change this claims principal. Anyway, this add scheme returns authentication builder, and this authentication builder is really a syntactic sugar, because if you would like, you can do pretty much anything you want using the authentication options and adding services on your own. This is actually the extension method. This is the authentication builder, and you see that this add scheme helper only will get the parameters and will put them into the right places within the iService collection. And then there are like couple convenience methods.
Is there any control over the order, which one fixing, or they have to be always these handlers programmed in a way that they don't touch whatever they are not supposed to touch, so the order doesn't matter?
Yeah. So in general, we will see the authentication options, but in general, it spins around this add scheme, and this simply adds the handlers or adds the schemes. So then you will get the handlers in the same order that you called this add scheme.
Sorry, I can see that the method add scheme helper is private. So what is supposed to call it?
No, we don't use this add scheme helper directly. We use this convenience method, this add scheme, add remote scheme, and add policy scheme, and it will only it's just a syntactic sugar that it will use this add scheme helper a different way, if you know, regarding the method you used. But the point of this slide really was that this builder is just a syntactic sugar. It doesn't do anything unnatural. And we use the authentication, and the next part is that in the app builder or in the configuration phase, we should add use authentication. And this use authentication actually does only two things. And one is kind of interesting. It adds a key to app properties to avoid duplicity. So, you know, the first adds the key, and the second will check the key and knows that, you know, there is something like that, or anyone can then check the properties and will instantly know that there is use authentication called, and that the middleware, the authentication middleware, is somewhere in the pipeline, and it will add the middleware, of course. And to get a look on the middleware, just let's mention three authentication features, because we were talking about the authentication result and the claims principal and these things. And all these things are stored in context features map. The authentication feature, despite its name, is only used to keep the original request path for possible challenges, that if the authentication fails, maybe there was like some redirects or something, and you want to be able to investigate what was really called and what's the thing that the user wants to authenticate. Then the HTTP authentication feature keeps the authenticated user. It should be standard that when the authentication is successful, you will overwrite the HTTP context user. But here is just another place where it can be get. And the rest is the result feature, the iAuthenticate result feature, and it keeps the authentication result, which may contain the exception, for example, with some explanation why the authentication failed, and a couple other interesting things from the authentication, like the authentication properties, I guess. So the authentication middleware, it actually does only two things. It can short-circuit pipeline because there is a special interface. It's called iAuthentication request handler, and it performs default authentication. So if you say that some scheme is default for you, it's performed for every request, and it's filled it's performed by this middleware. If you don't use default authentication, and if you don't want to short-circuit pipeline with iAuthentication request handler, you don't actually need this use authentication at all, because this use authentication only adds this middleware. And honestly, this gave me a big surprise a couple of years ago, because I didn't really know how it works. So I expected this middleware to actually, do the authentication. So I put breakpoints pretty much everywhere, and I was trying to call it, because I had an issue that I had an authentication middleware, and I really tried everything, but the authentication middleware was never called. And I was pretty confused because I added use authentication. The middleware was there and nothing was happening. And the part what I overlooked was that authentication handler provider, as we mentioned. And here we get all the handlers for the scheme. So far, so good. But but then you will get the actual handler, but you will get it as this iAuthentication request handler. And this iAuthentication request handler, it's another interface. And its only purpose is that when it returns true, the request is short-circuited. So nothing else is performed, and you return back basically what you have. So mostly 404 if you don't change it. So this one actually doesn't do what it seems to do, and the only thing is in this S. So just keep it in mind. And the rest is that when you set some default scheme, you see that you use this scheme provider to get the default authentication scheme. And if it's not now, aka you set some default authentication scheme, you will perform the authentication using the handler that you get, and if it's successful, you set correctly the user in the context and all the features that we mentioned. So that's the, let's say, rather niche flow actually, because mostly you use the authentication as part of authorization, and this uses authentication service, which is an implementation of iAuthentication service. And this service, on the other hand, doesn't change the context user. So it relies on the underlying policy that it will change it on its own. And there is a very strange cache behavior, by the way. It gave me a headache till I got it. But the idea is that you want to authenticate the context with some scheme, and it will do basically what the middleware does with the default scheme, but it will do it with some scheme that is required, and it will then return the result. So the underlying authorization policy will see, okay, there is authentication result, the user is authenticated, so we know who he is, and then we can like check if he can do what he wants. So if you again see that we still like keep all these flows, so I skipped the forbid async, but the challenge async is here. Again, we resolve the default challenge scheme and do all the heavy lifting that we saw.
What is this transform cache good for?
Yes, that's the strange cache behavior actually. And this transform cache is for if you use the cache transformation. It's sorry, the right name is iClaims transformation. Sorry. Then if you are in this authentication service, you may want to like change the principal somehow, and there is like a cache that will store the resulting principal, and then if it checks that the principal was already transformed, it won't transform it again, but it will return the transformed one. So you like transform it only once.
That's the default implementation.
Yes, yes. All these implementations are default implementations that I got from mostly source.net. And so, do you have any questions? Yeah, that's great. And now I have a short demo just to show you the things that we were talking about. So, oh my. So from the user's perspective, I use the default, let's say seed for web application. So I have this weather forecast controller. I guess there is no one who wouldn't ever see it. And in the program CS, I edit a couple authentications, and it will return a builder. Then we add a scheme. Here we have foo-bor authentication options, which are just the implementation of this authentication scheme options that we saw. And then a handler. I have a different handler for foo and for bar. And then I have a unified authentication handler for foo-bor, and this foo-bar is a default scheme. So I can now get through. Sorry, I have this use authentication right here. So you see that it adds the authentication middleware. and this. Sorry, I will try to change the resolution because it's really strange. Oh yeah, I guess it's better now. So we may go with breakpoint here, and another one is the authentication service. I hope I will guess. Correctly. So the authentication service, and here is the authenticate async, and I have a postman on another monitor, so you see that it only has the authorization header, and there is bar with my name, and in the controller I edit authorization, and this authorization will catch schemes foo and bar, which are the two we registered, and so let's just call it, and we will see what we will get. So first we will get into the middleware, and since there are no I authenticate request handlers, we will get to the default scheme, and oh my, sorry.
And the middleware was the .NET one, or?
Yes, is the authentication middleware that is added by the use authentication.
So that's the .NET one.
Yes. So this is the code we already saw. So then it will get the default authenticate, and it's an authentication scheme with foobar, because that's the one that we registered, and then we see that we got into authentication async, because we already used authorization, and sorry, I have more threads in the action. So since I used the authorization, we got into the authentication service, and then we get with the next call. So I got into the service a couple more times, and here, sorry, that was my debugging, but this only checks. This is the part of the authorization, and it will only check if the user is authenticated, and if the name is the name that we expected, and that's pretty much it. So then we are authenticated, and we got 200 here. So yeah, sorry for this to be a bit chaotic, because this monitor is a bit new for me. So that was like a quick demo about the parts that I talked about, and if you have any questions, please ask. Okay, then thank you for your attention, and yeah, enjoy the rest of the evening.